writer at a personalized health clinic, Hyderabad, and her research is focused mainly on personalized medicine, precision oncology, and pharmacogenomics. She is involved in a lot of work based on chronic and genetics of chronic pancreatitis, focusing on biomarkers. And she has worked as a lecturer at the University College of Women at Osmani University. She has earned her PhD from Osmani University as an SRF from UGC on the project titled Elucidation of Cytokine and Matrix Metalloprotein Gene Polymorphisms in the Pathogenesis of Chronic Pancreatitis. She has been a life member of the Indian Society of Human Genetics and of Bioclues, that is Bioinformatics Club for Experimental Scientists, and she has published for more than 20 peer-reviewed manuscripts, reviews, and book chapters. So with this brief introduction, I welcome you, ma'am, to our Landbix 2023. Over to you, ma'am, please.
Thank you, Nirani. Thank you for that introduction. Am I audible?
Yes, ma'am, and your slide is also visible, ma'am.
Yes, okay,
Yes,
thank you. Hearing the previous sessions, I just felt like quoting something before I start my talk. It's like, I'm a boy playing on the seashore and diverting myself now and finding a smoother pebble, and this the great ocean of truth lay all undiscovered before me. That was the quote by Sir Isaac Newton, because the talks till now had been generalized, very precise, and it was a very beautiful session until now. And I feel like a small guy small person in front of all the speakers still who gave their great talks. So coming to, can machines think? This was the question posed by the mathematician Dr. Alan Turing during the 1950s in his paper, which posed this question: can machines think? And this question has, this simple question has ushered into the era or the quest for artificial intelligence. So artificial intelligence is just not, nothing new. It's been there since many, many years. And terms like machine learning, artificial intelligence, and deep learning have all become science buzzwords in recent years. Can these technology be applied to saving our lives? Answer to that is a resounding yes, but there's a huge big but, because we need to tread carefully, slowly, and steadily if we want to have the best use of artificial intelligence in healthcare technology. Future developments in health science may actually depend on integrating rapidly growing computing technologies and methods into medical practice. And my talk is just to give you a very, very brief overview on what is actually right now happening, or with the help, how we are assisting or how we are taking the assistance of artificial intelligence in healthcare technologies or healthcare. One of the best example already being quoted by one of the previous speakers was about robotic surgery, artificial intelligence assisted robotic surgery. Robotic surgery is a method of surgery that allows doctors to perform complex surgical procedures with greater precision, control, and flexibility. AI was introduced into surgery more recently with a strong root in imaging, navigation, and early techniques focus on feature detection and computer-assisted intervention for both pre-operative planning and intraoperative guidance. There are made 4 areas of computer-aided intraoperative guidance in the surgeries that involve artificial intelligence techniques, namely shape instantiation, that is the reconstruction of the organs; endoscopic navigation, that is to visualize the inside, of the human body or any other animal body also for that matter; tissue tracking, that is soft tissue or optical biopsy tracking; and augmented reality. The objective of artificial intelligence is to boost the capability of surgical robotic systems in perceiving complex in vivo environments, conducting decision making, and performing the desired tasks with increased precision, safety, and efficiency. There have been a lot of, nano robots and surgical instruments which are being slowly used. But again, this needs to have human intervention also. Otherwise, things could go wrong. Another interesting, healthcare technology which uses artificial intelligence recently, which is virtual nursing assistants. Now, this is an AI-powered virtual assistant offers personalized experience to patients. It helps them to identify their illness based on symptoms, monitor their health status, remind them of, you know, medicine intake, doctor appointments, and so on and so forth. This is still under, somewhere in between. Yes, we have come to the stage where yes, we can rely completely on nursing assistants. So, in the start, we are somewhere in the middle. Then comes diagnostic imaging. This is a huge area where a lot of work is being done. And a persistent challenge in medicine is accurately and rapidly diagnosing patients when accessing a large number of scans or images. It requires a lot of time and effort from highly specialized operatives and is largely a manual process. You can see here, this is a AI assisted diagnostic system developed by Zhang, who identified COVID 19 pneumonia within 20 seconds. The 20 seconds worth of information which the AI tool could tell, behind it had years and years of training. And this is just one such successful story. You can teach artificial intelligence or models, we can make models to look for lesions, and it will remember and improve to the extent that it can exceed senior human experts while being incredibly fast. Imaging can now also help in the cognition, brain cognition. As Dr. Manoj had just pointed out, it's human brain is highly complex, and we are still trying to understand its mystery, how it thinks, how all these jumbled networks of neurons work in work in university to create even as simple as such as a finger moving, a thought coming. So we are still in the niche and very initial stages, I would say, in spite of all the years of work, we are trying to understand our brain complexity. And AI network is used to understand the human cognitive abilities and try to mimic to that and teach it to a machine or like a robot. So, imaging in medicine now involves sophisticated ways of analyzing every data point to distinguish disease from health and signal from noise. You can see that there are a lot of steps involved in image generation and image analysis, and then come to a simple conclusion of whether the given image is telling about a healthy tissue or a unhealthy tissue. So we have a lot of radiopharmaceuticals and radiochemistry being worked on, and instrumentation and image acquisition. How clear are we able to take the picture, and how accurate it is able to see. Then image reconstruction and post reconstruction image enhancements, so that the sensitivity and accuracy of the given result is close to 100%. So there are a lot of clinical intelligence and decision supports, enhanced reporting and imaging informatics, detection and diagnosis. And there are a lot of steps involved in this particular imaging modeling. And everybody has something to do here. So there's a lot of scope of work to do here. Now, coming to precision medicine. Now, precision medicine is also a medical model. If you look into the simple flow chart, you'll see that typically this is how any patient coming to a hospital goes through different procedures, processes, with an expected outcome of coming out being healthy. But if you see, right from a patient starts with starts engaging with a healthcare system, there's a lot of information gathered at each step, be it clinical history, be it physical examination, reference and consultation, diagnostic and testing, and communication of these diagnostics, and depending on that, the treatment and the outcome. So each step has a lot of data being generated. And this is where artificial intelligence and machine learning techniques are being used to understand, simplify the huge data being generated, be it right from the medical devices used for diagnosis or for the kind of whole genomic experiment where the sequencing have been is a part of this precision medicine. And here also there's a lot of data being generated, and this is where we take use of these algorithms to understand, simplify, and try to address the simple question of a patient who asks, why did I get this disease? Or how do I manage or treat this disease? So, these three simple questions behind that, there's a huge lot of data being here. But of course, as I told here, even though we say that AI helps resolve certain kind of issues like analyzing different images within a very fast, quicker phase, which might take a typical radiologist, a senior radiologist might take at least 20 minutes to look at those scans and all. But it is always the human intervention which gives the last word, not the AI. That we always have to remember. And the fundamental goal of the diagnosis of the disease lies in determining whether a patient is affected by a disease or not. And this also, the clinician is the one who will take up whether the decision made by a AI algorithm has to be taken forward or not. Because there are many factors here which goes into the model generation for especially translational precision medicine. Now, if you can see, we have early development where, typically basic science involves disease models, multi-omics, biomarkers, disease endotypes, and we do a lot of association studies. And the information which we have gathered here needs to be built into model-based data integration, and again, biomarker guided trial designs for drugs. And using artificial intelligence is just a means of using all these data generated at different parts to try to implement to a real world evidence, correlate with the real world evidence and use this for precision medicine. You can see that always, the precision medicine, which simply, if you ask me, it's all about the analysis of the complex data of an individual. But before we give out an answer, we have to take up all the evidence based works which been done on a typical cure or towards a management of a disease, right from clinical trials, omics data, and then we have to have this biomarker guided clinical trial designs which follows enrichment stratification strategy, etc. And then only we can come to the point of tailoring treatments or giving a personalized healthcare. You can see that, as Sir Dr. Manoj also had pointed this out, that artificial intelligence can also be used for novel drug development. So many of the bioinformatics and in silico based method try to filter out the useful and not so useful drug molecules for a given disease. So that makes like a 50% of the work done in silico. But the next part of the person would be obviously lead to the preclinical developments, clinical trials, and then only we can suggest a personalized cancer therapy. So there are a lot of opportunities and challenges associated through these various steps. And right now, this is where a lot of work being, a part of a lot of work being generated in human genetics or human trials is going on. So AI can help in designing molecules. We have something called digital healthcare right now. So, in today's rapidly changing healthcare landscape, the need for fast digital transformation is crucial in driving operational efficiencies, clinic care, clinical care delivery, and enhancing patient care while keeping costs at an optimal level. Because, in spite of we say we are using personalized medicine, it hasn't come down to the level where any person can afford it and try to reap the benefits. Even though we say the sequencing costs have come down, it still takes somewhere around 45,000 to 1 lakh for personalized healthcare treatment to be affordable for someone to afford. So that number is still huge, and not everyone is able to afford it. So this is where the public-private partnership as well as the government's initiatives can help try to bring this cost down so that each and every person can reap the benefits of this personalized medicine. And there are different steps involved using all the in artificial intelligence, machine learning, and deep learning, starting with precision oncology, drug discovery, imaging and digital pathology, next generation sequencing, and patient data management. Now, uh, trying to um, involve all these or include all these into a one system itself is a huge task, and still we are trying to still learn. We are still in a learning process to improvise so that a person can reap the benefits of all the technologies which we are talking about. Now, this is a recent publication which shows us how big data analytics and artificial intelligence is in healthcare. What kind of research is being done, and there's a huge plethora of information or work being done, and there are a lot of multiple types of algorithms, and which is exhaustive. It's it's like never ending. There are a lot of information coming in. How we use this data and how we analyze data keeps changing from person to person again. So there needs to be a kind of uniformities in the decisions or the in the results which we get. It's not like I've used one algorithm, I'm getting X result, and then I'm using another algorithm, I'm getting Y result. Which one to choose? So the choosing option of the results we get is still subject to human mind and our well, what do we say, well experimented and well proved theories of science only. We still are based on that only. So now we can see that right now we have a lot of information generated, from person as well as public data, which needs to be integrated. The data needs to be fused, integrated, stored, and depending on the requirements of what is it needed, small data sets or databases have to be created, and then we definitely need the help of using different kind of artificial and machine learning approaches to filter out to answer the question we are trying to answer, and then only we can come to a simple clinical decision support system which will be useful to all. And it has many steps involved, which though it's not just 8 here, but there are many steps involved. It starts with the study design on what we are trying to answer, data collection, then data labeling, model design, model training, model testing, reporting, and evaluation, which takes time. Even though the word artificial intelligence, deep learning all sounds very as if they are very fast, but behind that fastness again there needs to be a proper um, planning of what we are trying to prove here. And there are a lot of potential pitfalls here, which we should never forget with respect to dealing with artificial intelligence, especially in healthcare technologies, like uneven distribution of informatics, integration of biological data among heterogeneous sources, hazards, then privacy issues, and how to integrate the huge data which we generate from the various data points into a simple electronic health resource database so that all the patient has to do is just give their sample somewhere some day ago, and even after years should be able to benefit this just by going to that hospital, so that all the information should focus to one point. Then we have a lot of issues with the algorithms, which leads with redundant attributes, distribution of statistically independent attributes, reduced evidence and reproducibility, correct predictor, and gaining confidence of clinicians that AI produced results also is a huge uh, pitfall or disadvantage. Why? Because we may have developed this technology, we have to convince the consumers here, or the especially the uh, physicians who have to disseminate the information to the patient. So educating them at every in a simple way is again involves a lot of time. And but we would say that it's not so impossible, but taking them towards a new technology with a confidence requires a lot of evidence-based information. As I told you, ethical and social issues related to healthcare data collection, privacy, and protection is the foremost which we have to never forget while talking about all the advantages. And we know that precision public health has to face societal challenges, including racial disparities, environmental issues, climate, and general ethical concerns. Because an individual centric model, such as health avatar, poses a number of limitations because it may lack of higher level dynamics happening at the societal and environmental level. When I say healthcare, it is just not about an individual with a good health. That health involves many of these societal norms like disasters, food, welfare, health coverage, pollution, vector-borne diseases, racial disparity, because community, society, and ecological factors must be accounted on the top of the individual based, fine grained approach for precision medicine, which also needs to be taken care, included into all these AI driven models also, especially when we say about precision medicine. So here I take leave of giving a generalized overview of right now kind of where do we stand. Yes, we are using personalized medicine, precision medicine, but it is still evolving. We haven't said yes, we have done this, and this is where we are. It is slowly evolving and will keep changing with all these factors which needs to be included further in the research. Okay, thank you very much.
Thank you, ma'am. I think this talk was something blown out our minds, ma'am. It was amazing talk that you gave. So now the desk is open to the question answer session. Participants can unmute yourself and ask your questions to the speaker. Okay, so yeah, it was a wonderful talk, ma'am. I really felt like something. It was like overblown with all the things that you have looked upon and giving key insights upon each of the topics. That was amazing. So, ma'am,
can we take Indrani? Can we take a photo?
Sure, a special moment to share. So,
all of you can switch on your webcam.
So yeah, webcam. We can have a photo with our speaker, please.
Thank you, Rajul. Thank you, Manjari, for a wonderful talk. Yeah. Now the